Nowadays, we hear a lot about artificial intelligence being used to automate processes, something we've actually been doing for many years without its help. However, many of us who truly benefit from this tool in our daily work do so by interacting with it, and that's something it excels at. Many companies have bespoke applications, developed over years, where they've poured their knowledge and experience, and that's precisely where AI integration can make a real difference, turning assistants into living, self-updating documentation for the application itself. Helping users resolve issues and report them to support, with the technical details already prepared. Training new staff without diverting valuable human resources. Preserving expert knowledge, even when experienced employees move on. Communicating with each person in the language of their department, or even in their own native language. Guiding users within the application itself, interacting with the interface in a controlled and secure way. Of course, all of this passes through strict security filters. Assistants can only do what we explicitly allow them to do. But integrating AI into existing applications is no simple task. It takes experience, and quite a bit of trial and error. The aim of this project is to create a sandbox of open applications, a place to experiment freely, without the fear of breaking anything. A community where developers and other professionals, documenters, users, and trainers can learn together. The first project in this series is an adaptation of a chess database I published a few years ago on this very blog. I find it particularly interesting because it works with professional-grade servers such as MySQL, Oracle, and SQL Server. The database itself is quite simple, yet it can hold millions of records with complex relationships. It can manage several databases simultaneously and transfer games between them. It imports games from PGN files through a rather sophisticated input process. It offers multiple configuration options for assistants and detailed log files, extremely useful for debugging. But instead of merely talking about it, let's see it in action. Let's get started. The first thing we see is an application with no menus or toolbars, only a console on the right-hand side. This console is where we interact with both the AI assistants and the application itself. When it opens, a welcome message appears, offering the first basic instructions. At the top of the console, we find a toolbar, a text box for entering prompts, and 2 assistant lists. The toolbar buttons let us change the font, upload files to the assistant, enable voice responses, stop a conversation, or reset the context to start again. A drop-down menu gives us direct access to some of the selected assistant's tasks, such as opening forms. We can also open the assistant settings to modify key parameters, such as model parameters, its tools, initial instructions, or the colors used for its responses in the chat. These changes apply only to the current session, making them ideal for testing new configurations safely. We can also enable token logging in a CSV file, which can later be imported into the database to analyze cost and usage. The text editor works just like in other interfaces. Press Ctrl+Enter to send your prompt. The list on the left lets us choose which assistant will receive the prompt. The one on the right determines who will receive the reply. This also allows assistants to chat with each other. From the editor, we can force the use of a specific tool or even a particular function of the assistant. It's also possible to change the model for the next request using the drop-down list above the prompt.
You can also ask me to explain how the console works. I'm Chessmate, the assistant specialized in the application. In the chat, you'll see some of my reasoning and internal operations while I prepare each response. I can call application functions to highlight and comment on form controls, open dialog boxes, or click buttons to guide you visually. Each reply appears with a colored header, showing the responder and the originating player, whether that's the user, the application itself, or another assistant in the cast.
And what about the toolbar buttons?
Oh, right! I almost forgot about the toolbar buttons. Let me explain those real quick.
Alright, let's leave the console for now and move on to chess. I'd like to import a PGN file with some games.
Sure. I'll open the dialog so you can select the file. You can also choose another file to save any conversion errors if you'd like. Let me walk you through how this form works. Select one game from the list to preview it on the board, or select all the ones you want to import into the database. Press this button to view and play the selected game on the board. Click here to check all the games in the list, without having to select them one by one. When you're ready, click here to insert the checked games into the database. Would you like me to import all the games from this PGN? Or only specific ones?
Press the button to display the selected game.
Done! The selected game is now displayed on the board. Use back and next to move through the game. Reset returns to the starting position, and you can also toggle the board's side view.
Now, select all and press the Insert button.
You'll need to confirm whether you want to include games that already exist in the database. After that, the integration begins. Watch the progress bar to follow the process. Once finished, you can delete the PGN file if you no longer need it. That way, you'll avoid processing it again by mistake. Would you like me to open the game query form so you can view the newly imported games?
Not yet. What if I want to process many files at once? Doing that one by one could be exhausting.
No problem. There's an option to import as many PGN files as you like, completely unattended. Step 1. Here, you can select all the files you want to import. Step 2. Optionally, you can enable this setting to include games that already exist in the database. Why would you do that? For example, if they've been annotated by different people. Step 3. You can also tick this option to delete already imported files from disk. Files with errors won't be deleted, so you can fix them later. Step 4. Click here to start the import.
Alright, let's select a few files to test it. I see there's also an option to select another file to log errors.
That's right. Now you can leave the program running overnight, and by morning, all your games will be ready in the database.
Well, ready to search for some games in the database? Hello, I'm AIProv, the chess assistant for this application.
Let's see if you can find any games that ended in checkmate using a queenside castling.
Alright, I'll check the database documentation to see how that kind of search is done. Let's start by opening the query form. I've selected the Move Data query. I think that's the most appropriate one.
I'll open the filter editor to watch how the conditions are being built.
Event code 2 stands for checkmate. That needs to go in the filter. Queenside castling has the event code 512. That should be added as well. Running the query and no results. I'll try adding a condition so the move must be the last one. Still nothing. Alright, let's add the move text filter and give it a try. No luck. Sorry, there aren't any games like that in the database.
I found a game that ends in checkmate by castling. Let's add it to the database.
Sure thing. I'll open the form for you.
I've got it in PGN format. Send it to the board.
All set. The moves are now loaded on the board.
While we're at it, go through the moves and add some commentary.
White opens with e4, staking a claim in the center. Black responds with c5, entering the Sicilian defense. White develops the knight to f3, attacking e5 and strengthening central control. Black plays e6, supporting the d5 advance and preparing to develop the dark-squared bishop.
No additional chess knowledge or documentation was provided to the assistants. All of these comments are entirely their own, and later, we'll even see them play a match against each other. In this example, AIParov doesn't even have the online search tool enabled.
The final move has already been played, showing the moment of checkmate by queenside castling on the board.
Now that we've registered the game, repeat the search for checkmates by queenside castling.
Alright, let's see. We open the query form, select the Move Data query, add the filter conditions, and refresh. Got it. Here's the game we were looking for.
Don't worry, users won't need to wrestle with arithmetic or logical formulas. Let's clear what AIParov has written. For simpler filters, we'll use this drop-down menu by right-clicking the column we want to filter. Tick Filter, choose an operation, and type in the value or values you're looking for. For text searches, you can ignore case sensitivity. Once all filters are configured, press Refresh to display the results. It's also possible to search for the same value across several columns, for example, a player's name, whether playing white or black. Filters are cumulative, all the conditions in every row must be met. Of course, you can also remove unnecessary or incorrect ones. There are also more advanced filters designed to make complex searches easier. Let's compose one by selecting several cells, for instance, white, Morphy, year, 1858, or black, Mauryan, result, 0 to 1. Here we have, for example, the Move Events filter, which allows you to build a search like the one AIParov performed, but visually, and without formulas. We simply select checkmate, queenside castling, and specify that both must occur in the same move. This next filter lets you select one or more squares as the origin or destination of a move. In this example, we've chosen one origin square and several possible destinations. When viewing any of the games found using this or another filter, the moves that meet the filter's conditions are shown in purple, so they can be located easily. The position filter allows us to search for a total or partial configuration of the board. We can place a piece of a specific color on a square to find positions where that square is occupied by that piece. In advanced mode, we can define a smaller rectangular area or the entire board. Pieces with no specific color will match both white and black. It's also possible to place more than one piece on the same square to broaden the search options. This is the type of expression the assistants use to build position search conditions, though, if you feel like it, you can also enter them manually from the graphical interface. This particular filter is quite heavy. A perfect time to grab a coffee or take a short break. 12 minutes and 19 seconds, to be exact. The server is Oracle 19c, and the positions table contains 14.5 million records. And here's our position on the board, the two queens on e3 and g3, and a black rook between them, on f6. In this other one, instead of the black rook, we have a black bishop. Now, let's go back to Chessmate, to explore a few more possibilities of this query form. How many types of database servers do we have registered?
We've got 3 server types registered: SQL Server, Oracle, and MySQL.
And how many connections?
These database connections are registered: Oracle Local, which is the default, SQL Server Local, MySQL Local, and Remote MySQL.
Open a query window for each of them.
All done. I've opened a query window for each connection.
Let's select a game, perhaps one played by Botvinnik. Here we have 2 buttons that let us either edit or play the game. They're quite similar, but I'll choose play because it's the more complete option. We already saw edit earlier when we loaded the Checkmate by Castling game. By clicking any move in this panel, the board jumps to the corresponding position. And in this small list on the left, we can search for other games where the same position occurred at some point. When you select each game, you'll see a small board preview with the position and the next end moves. These games can also be opened in a separate window, where you can only replay them. Both games are now aligned on the same position. Let's look at a few more options. This button lets us add tags to the selected games. These tags are metadata about the game, which can later be used for searches as well. This one deletes the selected games from the database. It asks for confirmation, so don't worry. And this one also deletes games, but only from the list. They are not actually removed from the database. Let's finish this short tour of chess by showing how to use metadata to select games, and how to export them to files or another server. To filter by tags, we need to select this option. As usual, this button opens the panel of special filters. What's special about tag filters is simply that the set of values is predefined by the tags we already have. The tag's value, however, is up to us. We can sort the rows by clicking on the column headers. This drop-down shows the export options: export the list to Excel, export to another database, and export to a PGN file. I'll now select a few rows to export to a PGN file. This button exports the data, either the entire list or just the selected games. You'll need to provide a file name. You should also indicate whether you want to include the game annotations. Here is the resulting PGN file. To export to another database, first select the destination connection from this drop-down. Then choose the option in the other drop-down and use the same buttons as before to export. It doesn't matter if the database engines are different, the conversion is transparent. This process can take a little while if you export a large number of games. You can also export the entire database to another server. But in that case, I wouldn't recommend waiting around for it to finish. I could use a short break now. I'll leave you in Conficio's capable hands. Conficio, open the application settings and walk us through them, would you?
Hi there, I'm Conficio, the configuration assistant. Right here you've got the main settings dialog. Any changes you make won't be saved until you hit the OK button. And these are the parameters. Select the name of the default database connection. This one sets the maximum number of simultaneous connections allowed per server. Here you pick the folder for documents, notes and such. Same here, but for configuration files. This is the folder where PGN files are stored. And this one's where the application logs will be written. This file's quite an important one, it defines all the functions assigned to us assistants. This one contains database-specific queries used during exports. Another key file, that's the console's assistance configuration. This one sets up how assistance instructions and documentation updates are handled. In this file, you'll find the record of every function call the assistants make and the responses from the app. And this last one, logs token usage for each API call the assistants make. You can have more than one console configuration. Choose the default one right here. You don't want anyone stealing your passwords or API keys. You'll have to select a credentials store to keep them safe. Only the name you give it is stored in the config files, not the secret itself.
And what about the connection strings?
At the moment there are 4 connection strings defined, one for Oracle, one for SQL Server, and 2 for MySQL.
Right, but can they be edited from here?
Connection strings are created or modified through a different dialog box. Would you like to create a new one, or edit an existing one?
I'd like to create a new one.
This dialog's fairly simple, I'll show you quickly. Pick the type of server from this drop-down. Type a name for the connection. Click this button to open the connection data dialog. Then enter the server name or IP, the database name, user and password, and give it a go with this button to test the connection. Right, so, time for some proper setup. How about we crack on and create assistants?
Yes, I'd like to create a new assistant.
I'll pop open the API items editor. I've selected an OpenAI API assistant. Right now the app only supports this provider's APIs, but adding new providers is fairly straightforward. If there are more items of this type in the cloud that aren't in your config files, you'll see them in this other drop-down.
Assistants API is nearly obsolete now. I'm going to choose Chat Responses, which maps to the Responses API's, OpenAI's most advanced option. Now, the existing assistants of this type are loaded, so we can edit them. I'll press the button to create the new assistant. Here we can see the assistant's parameters. They all have a unique identifier. I'll rename it to Botvinnik, it'll be a chess player. I'll also change the description. From this drop-down we can select the model. I'll pick a more advanced one. If the model supports it, you can also select a reasoning level. Careful, if the model doesn't support reasoning, choosing one will cause an error when you use the assistant. And even when it's supported, enabling higher reasoning can slow responses down quite a bit. Press this button to save all changes to both the local configuration and the cloud. Now I'll create a data repository to store documents, what OpenAI calls a vector store. These are the vector stores for the other 3 assistants. Clicking here again creates another one for Botvinnik. Renaming it for clear identification should do the trick. Hit save again, and we're all set. Here you can see the vector stores for every assistant. As you can tell, creating new assistants is straightforward, but the story doesn't end there.
All set. Now, not quite, we still need to add it to the team.
I'd like to edit the console configuration.
Sure thing, I'll open the form for you, straight away. Step 1, pick the play you want to edit here, or click the Add New Play button. Step 2, here's the play's property tree. When you select certain nodes, you can tweak their settings. You can also tick this box if you'd like to make it the default play. This drop-down shows the items you can add to some of the nodes. The Change Active Play button loads the selected play into the console. Mind you, that restarts the chat and clears the context. The Properties panel here lets you edit the settings of the selected node. Don't forget to save your changes once you're done. Well then, you've got all the directions you need to make the changes yourself. Shall I do it for you?
Thanks Conficio, I think I'll manage on my own. First, we select the cast node, where the list of assistants is stored. In this drop-down, we'll find the elements that can be added to the node. Let's pick Botvinnik and click this button to add it. There it is on the list. Now, let's select it for configuration. We'll give it some initial instructions, briefly describing its role in the team. Interactions with the application itself aren't detailed here. Another option, and usually the preferred one, is to save the instructions in a text file inside the data directory, and reference it using the file prefix. It's a good idea to change the colors to make the chat responses easier to tell apart. This is the list of services. Services are sets of functions that an assistant can use to interact with the application. Each service adds specific system prompt instructions. Automation lets the assistant work with forms. ChessPlayer interacts with chessboards. Configuration accesses app settings. Memory notes reads and writes notes. Query database handles database queries. And user interface provides access to, and control over, the application's forms in general. For Botvinnik, I'll select ChessPlayer only. The last step is assigning a vector store. To do that, we select the Assets node in its configuration. Then, pick the vector store from the drop-down and press the button to add it. Finally, click Save, and Botvinnik is ready to go. Let's say hello to Botvinnik.
Hey there, Zugzwan. How can I help you today? If you'd like, we can play a game of chess.
Let's finish our overview of the configuration by looking at document and instruction updates.
Right, here you've got the structure of documents and instructions for both the assistants and their services. When this button's active, you can add documents to the selected node. With this other button, you can open the selected document to edit it. And this one applies the updates. It uploads the documents to the assistant's vector stores. Here, just like in the other forms, you can edit the properties of the selected node. File cleanup patterns are used to clear temporary files each time the app starts. Here's the full list of assistants. Tick this box if you'd like to refresh an assistant's instructions, handy if you've saved them in a file. Here's the list of services. These are the documents assigned to each service. By ticking these boxes, you can update or remove them from the vector stores of the assistants that use that service. Hit Update, and that's it, grand job. Mind you, this operation might take a wee bit of time.
How do you install this application? Let me walk you through it. To use it, you'll need an access key for the OpenAI APIs. You'll also need to install a database server, Oracle, MySQL, or SQL Server. Once the server is installed, you'll have to create the database using the provided scripts. There are 3 scripts for each type of server. Download the executables, or the project's source code if you prefer to compile it yourself, following the instructions in the article published on my blog. You'll find all the SQL scripts inside the scripts folder. I'll go over the installation for MySQL only, as it's the lightest and simplest server to set up. If you're not sure how to install the server, I'd recommend asking your favorite AI assistant. I'm sure it knows how to do it. We're now in MySQL Workbench, which is installed together with the database server. The file named after the server, in this case mysql.sql, is the script that creates the database schema and a user with permission to access it. The file ending in objects, mysql_objects.sql, is the script that creates the tables and the initial data. Finally, the file ending in code, mysql_code.sql, contains several stored procedures and functions, mainly used to calculate statistics. If you've installed MySQL, you can also download from my blog a complete database with over 200,000 games. You can import it into your server and only need to create a user and grant access to the schema. It's called chess_db. Once that's done, you can start the program, and you'll see a message telling you there are a few things to configure. The first configuration step is the credential store. I recommend using environment variables or Windows Credential Manager. Next, you'll need to enter a credential name and your OpenAI API key. This is one of the pieces of information that will be stored securely. You'll also need to set up the database connection. Choose the right connector for your server, give the connection a name, and set a value for the maximum number of simultaneous connections. Open the connection string dialog, type the server name or IP address, the database name, and the username and password. Don't forget to test the connection before continuing. Connection strings are also stored securely. The next step is to configure the 3 initial assistants. You can also choose a username if you wish. The first assistant is the application specialist, which I've called Chessmate, though you can name it however you like. As the assistant type, I recommend chat responses. Also choose the model and its distinctive chat colors. The other 2 assistants are the Chess Expert, which I've called AIParov, and the Configuration Assistant, Conficio. They're set up in exactly the same way. And that's it. The vector stores are created, the documents are uploaded, and the application is ready to use. To finish, I'll leave you with a game played between AIParov and Botvinnik. The match never actually reached the end. Botvinnik got a bit tangled up with the board position, and the two ended up arguing endlessly over which moves were right or wrong. Still, it's rather entertaining to watch them in action.
Game started. I open with e4. Good luck to both sides.
I respond with e5, taking the center.
Knight to f3, attacking e5 and developing a piece.
Knight c6, defending e5 and developing a piece as well.
Bishop to b5, entering the Ruy Lopez. More pressure on c6 and building central tension.
a6, challenging the bishop, classic Ruy Lopez stuff.
Bishop a4, keeping the bishop active and maintaining pressure.
Knight f6, attacking e4 and continuing development.
Kingside castling.
Bishop e7, getting ready to castle.
Rook e1, reinforcing e4 and preparing for d4.
b5, hitting the bishop and gaining space on the queen side.
Bishop b3, retreating to safety while still watching f7.
d6, supporting the center and freeing my light-squared bishop.
c3, preparing d4 and strengthening the center.
Kingside castling.
h3, giving the king some air and preventing any bishop g4.
Knight a5. After that bishop on b3. Maybe a trade soon.
Bishop c2, keeping it on the diagonal and ready for future action.
c5. Expanding on the queen side and controlling d4.
d4, striking in the center and opening the position.
Queen c7. Defending e5 and keeping the center solid.
Knight bd2, reinforcing the center and connecting the rooks.
Bishop d7. Linking the rooks and supporting the c5 pawn.
Knight f1, heading for g3 or e3 to increase control.
Rook ac8. Bringing pressure to the c-file and on c2.
Knight g3, maneuver complete, adding pressure on the king side.
Knight c6. Coming back from a5 to reinforce the center.
And so they carried on for quite some time, but we'll stop here. Thank you for staying with us till the end.
Septincidun, nu hi habitava aliquam tincidun, orcitur pisclinchilla eros, utul trices orcimagna iuero. Peientes que ficitur felis nec nisi tempes gravida. Donec sollicitudin urna aceros fermentum, quis victem odio tincidun. Nu hi amacer purus logotis,